It's pretty hard to miss all the chatter about artificial intelligence these days.
Oh, definitely. It's everywhere.
And I think for a lot of people, maybe for you listening, a central question just pops right up. How is this going to, reshape our jobs, our creative work?
It's a really natural question. There's this tangible mix of excitement and, well, apprehension around AI. And that's totally understandable. It's powerful stuff.
And that's exactly what we're digging into today. We want to explore how AI might fundamentally change, programming specifically. We're basing this on a really interesting piece called How Will AI Change Programming? Think of this as our way to bring you up to speed quickly on some complex ideas.
Yeah, maybe offer a few surprising facts along the way. We'll try to keep the really deep tech talk, manageable.
Our goal is just to break it down, look at some history, see if we can figure out where things might be headed.
Right. And historical parallels can be surprisingly useful here.
Okay, so to really get a handle on this, let's actually go back, way back, like 19th century. Okay.
Picture the Luddites. You've probably heard the name, right? These were skilled craftspeople, artisans, who weren't exactly fans of the new power looms showing up in factories.
It's a classic story.
And it's a narrative that kind of surprisingly echoes a lot of the conversations we're having right now about AI.
That historical comparison is really key, I think. The Luddites, they were worried about losing their jobs, yes, but also about the quality of the work declining because of this new automation.
Right.
But what's really insightful, and the source highlights this, is that their resistance wasn't necessarily just against machines per se. They already used machines.
Ah, okay.
It was more about how these new machines were being used, the potential for deskilling their trades, losing control.
So it wasn't just machines bad.
No, not entirely. It seems that it was more nuanced. It was about that shift in power. Who controlled production? Who benefited? And that resonates a lot with today's anxieties about AI, doesn't it?
Yeah.
Who's really in control here? Okay, let's stick with these Luddites for a sec. So these were skilled workers, high-end weavers, let's say. Power looms arrive, immediate fear. Uh-oh, there goes my job.
Yep.
And the stuff we make won't be as good.
It sounds really familiar when people talk about AI writing articles or generating code.
It does. And as you said, the article we're looking at emphasizes it wasn't just any machinery, but the manner, the way these new machines were going to be used. That was the crux of it.
Which directly parallels the AI conversation today across so many industries.
Exactly. It's not just, will a task be automated, but how will this affect my skills? What will my job even look like?
Yeah.
And remember, the Luddite thing happened during the Industrial Revolution. A massive upheaval. It did cause huge job displacement, no question.
Well,
but the bigger picture, the long-term outcome, was the creation of entirely new kinds of jobs, new possibilities nobody saw coming.
right. So the question is, are we just seeing that cycle again, but maybe faster? That's the million-dollar question, isn't it? The source definitely brings up the speed. Things felt fast to people back then, but looking back, it seems almost glacial compared to tech changes today.
It does feel incredibly rapid now.
And it probably is, objectively. Yeah. But the source makes a smart point. People living through those earlier changes likely felt their pace was incredibly fast, too. Our perception of speed is kind of relative.
That makes sense. And the piece we're looking at, it touches on why things seem to accelerate so much now. It's about building on what's already there, existing infrastructure.
Exactly. Think about smartphones. They exploded because the mobile networks were basically already in place.
Or, all our home gadgets. They took off because we already had electricity wired into almost every house.
Right. It's like each new layer gets a massive head start. It doesn't have to build everything from the ground up. New tech thrives when it can plug into existing systems.
Okay, so we've got the historical analogy, the Luddites, the speed question. Now let's pivot specifically to programming, because the source makes this really compelling argument that programming itself isn't static. It's been automating itself, abstracting itself for decades.
That's such a crucial point. Abstraction is key here, hiding the messy details so programmers can work at a higher level.
Yeah, more human readable.
Programming has this long history of evolving, becoming less about the raw machine. If you go way back, really back.
You were literally flipping switches on a panel, right?
Yep.
Setting memory addresses, putting in values in binary, hitting enter with another switch. That was coding.
That was it. Pure binary, directly talking to the hardware. Your code was physical.
Wow.
Then came a big step, paper tape, punch cards. Suddenly, you could prepare your code offline, record it.
And crucially, reuse it. No more flipping the same switches over and over.
Exactly. Reusability was huge.
Yeah.
A massive efficiency gain, you'd imagine.
Must have felt revolutionary. But still, the code on those tapes, those cards, it was still basically binary, just holes instead of switches.
Still pretty low level, yes. The next big leap was assembly language. That was a major move towards abstraction.
Using those mnemonics, right? Little codes that were easier for humans to remember.
Right. Mnemonics that then got translated into the actual binary the machine understood. A layer of translation appeared.
And then eventually, keyboards. Teletypes first, then screens. Typing commands.
Which felt much more interactive, much closer to how we think of programming today.
And the source points out, with each of these steps, a specific job or skill kind of faded. Like, nobody hand punches paper tape anymore, unless maybe you're in a museum.
Right.
And you have to wonder, did people worry then? When assembly language started giving way to higher level languages like Fortran or COBOL, did assembly experts think, am I obsolete?
It's very likely. The article even notes that deep assembly knowledge isn't nearly as common or required today for most programmers. That specific, laborious task of hand-punching tape, gone. It mirrors today's concerns about AI making certain coding tasks just disappear.
It's a pattern. Each step towards more abstraction, more automation within programming itself, changed the required skills, changed the job.
Precisely. The rise of compilers, those tools that translate high-level language into machine code, definitely reduced the need for universal assembly expertise. This whole history provides a framework for thinking about AI's potential impact now. It's just the next step, perhaps a much bigger one.
Which brings us to a central question the source asks. Have we seen any AI killer apps yet, specifically for programming?
Yeah, defining killer app is important here.
Yeah.
It's that one application that makes you have to buy the hardware or adopt the tech. Like spreadsheets were for early PCs, maybe, or word processors.
Right, the thing that justifies the whole investment. So what could those be for AI in the programming world?
Well, the article suggests a few really interesting possibilities. One is something called Unified Natural Language Query.
Okay, what's that?
Imagine asking a database a question, just in plain English, like you'd ask a person. And the AI just figures it out and generates the complex SQL code needed to get the answer. For generating reports, accessing data, it could be huge.
Wow, so you wouldn't need to be a SQL expert anymore just to pull some specific information?
Potentially, yes. It would make data much more accessible to way more people. Think about business users, researchers, anyone who needs info from a database but doesn't have the coding skills. Natural language processing, NLP, is the tech behind that.
That does sound incredibly useful, really democratizing access to data.
It lowers that barrier to entry significantly, makes interacting with complex systems much more intuitive.
Okay, what else? What's another potential killer app?
The second idea is maybe a bit further out. Universal assistants.
Assistants, like Alexa or Siri, but for coding.
Sort of, but much more powerful and versatile. Imagine AI helpers you can talk to verbally about almost any subject. They'd act like virtual staff members, each maybe with different specializations. Need help debugging? Talk to the debugging assistant. Need system design ideas? Talk to the architecture assistant. And the source mentions scalability.
So if you have more work, you just spin up more virtual assistants.
That's the idea. It completely changes how you might think about team structure, project resources, huge potential for flexibility.
That's a pretty radical shift to think about.
It really is. The source also suggests that maybe before we get those universal assistants, we'll see more specialized AI-powered agents.
Agents? How are they different?
Think of them as more focused. They wouldn't be generalists, but experts at specific tasks within the programming workflow, maybe optimizing code or generating test cases or automated deployments, bringing more AI control into the existing automation pipeline.
Okay, so more like smart tools for specific jobs, arriving sooner perhaps.
That seems to be the suggestion, yeah.
So it really sounds like the programmer's role is headed for some pretty big changes. The source seems convinced that programmers are going to become even more abstracted from the actual lines of code.
That feels like a very likely outcome, doesn't it? As AI handles more of the direct coding, the human programmer's focus probably shifts upwards.
Upwards,
towards the higher level stuff. System design, overall architecture, really understanding the problem you're trying to solve, defining the goals clearly. It becomes less about the syntax of the code.
And more about telling the AI what to build and making sure it builds the right thing, guiding the AI coder, essentially.
Exactly. More strategic, less tactical maybe.
Yeah.
Ensuring the AI understands the requirements, the constraints, the business logic, the design phase becomes even more critical.
Fascinating. It's a different skill set, or at least a different emphasis.
It could be, yeah.
But the source, it ends on this really provocative note. It basically asks, okay, these are the applications we can sort of see now, but what are the really disruptive things? The stuff that will grow out of AI, maybe things we can't even imagine yet.
The over-the-horizon stuff.
Yeah, the truly game-changing innovations that AI itself will enable, maybe in the near to medium future.
And that's the great unknown, isn't it? And maybe the most exciting part. We can speculate about AI writing code or assisting programmers, but the truly transformative things might be entirely new ways of creating software, or whole new categories of applications that are only possible because of AI, things we just haven't conceived of.
Okay, so let's just quickly recap. We've looked back at history, the Luddites, saw that fears about automation aren't exactly new.
Right. Disruption happens, but new things emerge.
We saw how programming itself has always been automating, abstracting away the low-level details.
It's a process that's been going on for decades.
And we've talked about some potential killer apps for AI and programming natural language queries, maybe those universal assistants or agents.
Yeah, things that could really change the day-to-day workflow.
So it seems pretty clear that while AI will automate some tasks, maybe even whole roles as we know them now, it's also very likely to create new opportunities, new kinds of work, even if we can't quite picture them yet.
That's generally been the pattern with major technological shifts. Some skills become less relevant, but others become more valuable. Adaptability, focusing on those higher-level design and problem-solving skills, seems key.
Which brings us right back to that final thought-provoker from the source. But what are the disruptive technologies that will develop out of AI projects in the near to medium future? What's hiding just over that horizon? It really makes you think, doesn't it? And maybe for you listening, it raises that question. Given the tech we have now, the infrastructure, what completely new things could AI unlock by building on that? What haven't we thought of?
It's a great question to ponder. Well, one thing seems certain, echoing that final line of the piece we discussed.
Yeah.
We're definitely in for interesting times. Thanks for joining us for this deep dive.